Everybody, this is going to be a quick demo on the Accumulator Combiner Reducer, rather ludicrously named interface that talks about exactly what it does. It accumulates, combines, and reduces things. And part of the MapReduce framework is you're going to customize it with one of these. I have a simple method that returns that it exists, and but it's used in MapReduce all along with the mapper. As you recall, there are 5 different customization methods. The map lives on the mapper. These other 4 all live on Accumulator Combiner Reducer. We're going to build it in a second, so let's just do it there, or talk about it there. You can see it has these 4 methods: create a container, mutable container, accumulate some item into that container, combine 2 containers together, and then the big one, to take a container and reduce it down into its final value. You can see the V, A, and R that match up with the EKVAR part, the value type, the mutable container type, and reduction type. And in the total credits client that we've been building, this is this part where I create this summing double one, which we'll build in a second. And we pass it in here. It is, of course, used during MapReduce all. Let's build this right now. And so if I come over here, we have our client again, which I can run. You can see it's going to throw an exception because I changed it from working to throwing a not yet implemented exception. You can see here, the first time it tries to create a mutable container, it goes poorly right here. In this create mutable container. So let's go ahead and build it. Really quickly, you can see I've made this thing implement one of these Accumulator Combiner Reducers. If I tunnel in, you can see the 4 methods that I was showing you a moment ago. We're going to make it so that we're going to sum up a bunch of doubles. So every key value pair, for every key we encounter, someone's going to create a mutable container. We'll return one of those. And so what I like to do sometimes, we're going to just do this, let's return a new linked list. What I usually do is, if I don't know the size just in these classes, I'll return a linked list and I'll return an array list, and I'll set its capacity. If I don't know it, Josh Block sort of famously says, array list is faster in all cases, so why would you ever do that? So maybe I'll just do that here. We'll use an array list instead of a linked list. And so that's the first thing. Anytime somebody sees a key, new key, they're going to create one of these. Notice key is not in this guy, right? So the key never gets passed to us, but we'll be dealing with these values, creating mutable containers, and then reducing it later. And so we need to be able to create containers whenever one of those keys is encountered, but no one tells us about the key. Accumulate, this is going to be very exciting. Somebody passed me a list of doubles, and it's got a container and an item. What I like to do to add things, to accumulate things into lists, is I just add them. So we're just going to add an item into that container. Combine, which is used in more, like I've said before, more sophisticated ones. Again, it's going to pass us this container A, container B. By definition, we're always supposed to do combine container B into combine container B into container A. I'm going to call add all on container B and add it into container A. That will mutate this guy. There are some interfaces that do MapReduce where you would take them both and you could do whatever you want as long as you returned it. We've had students make mistakes, so I've made it very explicit. You combine B into A at all times. And finally, this is going to be, these 3 methods, this is exactly how classic MapReduce works. You could always, the mutable container was always a list. You would always accumulate it by adding them, and you would always combine them together. Things like Spark and more sophisticated frameworks have started to allow you to control this, which is why we're allowing you to control it. And we'll build more specific one later. You can think about, how would I sum the doubles of all these doubles that come in without creating a list? You could do that in a much more efficient way. You could just add them in as they came in. We're going to build the classic MapReduce first, and then later we'll build a more sophisticated one. For now, we're just building sort of a classic MapReduce style. Get them all on a list. Combine them, accumulating whatever you need while you're done. When you go to reduce them, pass me all of them, and I'll sum them up. How I like to do this is say double sum equals 0, and then for double value in container, sum plus equals value, and I return that value. I return the sum, and we should be good. And so now I have a perfectly valid one. Let's go back to the client, and if I run it, now we'll no longer throw these exceptions. It'll produce the beautiful values that I want. So this is how you build just a fully fledged Accumulator Combiner Reducer, and the MapReduce framework will use that. So I customize it by passing that guy in. When this MapReduce all, which you will be able to build multiple versions of this, gets past everybody, it's going to use this to produce this final answer for you. So hopefully this will help, and hopefully you'll enjoy this assignment.